Hello. We'll get started in a moment. I forgot something. Just going to set up my folder. If you recall last time, I didn't find a great way to do it. I just went via the files. I'm going to do that again. Overflow, streaming, processing. Let's make a new one. So we're on D21809. Today is 28th. And we're going to do something like flipnote. Not really. D201809 29. Oh, 28. Flipnote. Okay. Let's just check we got all our ducks in a row with a quick call to background. 255 is white. We want black. And run it. Not a valid sketch folder. I typed something wrong. D2018098 underscore flipnote. Okay, so what's it complaining about? Not a valid sketch folder because this does not exist. So it's looking for a folder with the same name as the file. 2018-09-28. 2018-09-28. 2018-09-28. Done something wrong there. Oh, I didn't call that a .pde. Okay. There we go. Should have known. And we got a little black window. Good. Now we are up and running. Excuse the phone. Put that on silent. Okie dokies. One thing I wanted to show you guys before we get started, a kind of explanation of where we're at, where we're going, what this is all about, is the code train. So this is going to open up the stream, which is going to be a bit weird, but now we'll find the code train. Coding train. This is something that I found after I started doing these streams, when I was looking around for other people doing streams of processing code, and I found this thing. It looks like it's for preschoolers. I don't think it's actually for preschoolers. This chap here is Daniel Shipman, the guy responsible for processing the language, and he's got these very light-hearted videos where he does live coding with processing. So that's kind of what we do here, right? Live coding with processing. But you won't see me dressed up like a train conductor. You won't see fancy graphics. So I wanted to explain, well, I want to point you to this first of all, because it's interesting. I've been watching them in the background and having quite a lot of fun. He does some more advanced demonstrations, coding challenges, as in he takes it further than we take it here in these videos. But he does that by standing on some giant shoulders. What I mean by that is taking advantage of some existing functionality and then building on that. A lot of these are showing you how to use an advanced function. We experimented a little bit with that last time when we did the lerp function, but we then wanted to see how to write that lerp function, and we wanted to experiment with other lerp functions. I think that's a good example of how this stream, you can expect this stream to differ from something like the coding train. The coding train is wonderful for showing you how to quickly and easily get to a really exciting processing program. And one of the reasons I like using processing is that I can put something exciting and interesting on the screen. But I am utterly brutal about wanting to understand all the nitty-gritty details of what's going on. That comes from me being a university academic. It comes from me being a deeply interested in programming. What you get out of that is an understanding of the foundations on which the programming sits, and you have, I think, much more transferable knowledge. And a big aim here when you're in a university teaching people how to program is not just to teach them how to make a Starfield example, although that's quite an interesting one. It's to teach them generalizable skills. So you'll see me doing something similar to the coding train. So if you're at all interested in this, you'll be interested in the coding train as well, but more heavily focusing on not letting any details slip past without trying to explain it. And also we'll expand beyond processing in this particular stream. We'll do Java programs and other things as well. We're doing processing just at the moment because that's starting it off as a kind of experiment, but it'll grow. And we'll do many, many more things from the types of teaching we do. So coding train, check it out, quite nice. And he's extremely charismatic, very interesting, and he has some guest people as well. You can see he goes beyond processing. Oh, another thing is all his examples are done using the latest versions of processing, the latest and greatest. And the latest and greatest processing is P5.js, which does processing in JavaScript. And there's a lot of reasons to be excited about that, but we have a teaching system that's a progression of Java technologies from the simplest to the most complicated, so we keep using Java processing because it's a nice foundation for that. Alright, what do I mean by flipnote? What on earth am I wanting to make this time? Okay, I really like programs that work as tooling to help you create something else. So I guess Photoshop is an example of that. It's a program you use, but it helps you be creative in other ways. And I really like, as a fun processing example, especially once you've got the capabilities of objects and arrays and strings and things, to do Microsoft Paint style programs, although vector-based ones. So I'm combining the two here. I'm trying to make a program that will. So Flipnote was a Nintendo program, excuse me, that would let you create little animations. So we're going to touch upon that here. You draw one picture and it becomes a frame of the animation, then you draw another picture. I also like it because it's kind of a recursive thing. What do we do as we're processing programmers is we describe what one frame should look like and describe what the next frame should look like, and processing displays all those frames to us. So we're using a processing program to then allow the user of the program to make their own animation without any programming at all. So I'll show you what I mean. We'll start off with a program that it has 3 points that it knows about. It asks the user, or waits for the user to give it those 3 points, and then draws a triangle based on them. Okay. So if I'm going to draw any old triangle, I need to have x1, y1, x2, y2, x3, y3, the x and y of each of the points of the triangle. Okay, so that's a fun shortcut to create myself some processing variables. They'll all initialize to 0, but I'll do that by hand. I'll do that myself as well. And x3 equals 0, y3 equals 0. So all I've done here is set up the variables. I'll set the size of the screen as well. I like to do that as the first line. There's no logical reason for that, but it fits better, I think, with some versions of processing. And all I'm going to do now, this is just a program that has those 6 variables and draws a triangle based on those 6 variables. But before I do that, I'm going to check to see if processing has a triangle function. Probably not, but we're going to look. Don't need that one. Firefox is gone, so I'll have to wait for it to, there we go. And now I thought I'd made the changes I needed to on my computer to stop that shearing, but I can see it's still happening, so apologies for that, and I'll fiddle with the settings yet again. It's only happening on streaming, not recording, which makes it hard to test. And you can hear the wind whistling through my window. Do your primitives: arc, ellipse, line, point, quad, rectangle, triangle. We've got it. Okay. So triangle takes the 1, 2, 3, 4, 5, 6 parameters, just like we might expect. And it's x1, y1, x2, y2, x3, y3. Well, it's what we called ours, so this is going to be quite simple. Triangle, x1, y1, x2, y2, x3, y3, and we can run that. That won't do anything though, right? Because it's, well, it'll do something. It'll draw a triangle in position 0, 0, 0, 0, 0. Tiny little triangle. Actually, I won't be able to see it, I think, because it's going to have a black background with a white. So we'll give it a white fill, and we'll give it a white stroke as well. Now we might just be able to see it as a single dot. No, I don't think we can, because it's a triangle from 0, 0, 0, 0, so it doesn't actually go anywhere. To actually see that triangle, we've got to set the x1, y1, x2, y2 to something other than those 0 points. Now I could do that here. Oh, let's start with that. Let's move it to 10, 10. Now we'll actually get a line. I'm suspecting there it is. So that's partly a triangle, and then if I make x2, y2, 20, 20, 0, that'll give me something that's a bit like a triangle. Well, it's exactly a triangle. There we go. I've got my little triangle at the top of the screen now. But I want the user to control the triangle, because this is something for the user to be able to input values. So what I'm going to say is that every time the user clicks the mouse somewhere on the screen, I would like to set that to one of the corners. But then the question is, which corner? So I can make a version of this that's easy for the user, but instead I'm going to make a version of this that's easy for me. Anytime I want to do something with mouse, let's make it do the third corner every time. So mouse pressed is the function that gets run anytime the mouse is pressed, and I'm going to say I want to set that last point to wherever the mouse currently is. And processing, of course, gives me the mouse X and the mouse Y to find those out. So wherever the mouse was when the press happens, those two values will go into the fields, into the variables x3 and y3, and they'll get reset from 0, and my triangle would change shape. So now we can see that happening. Now the other two aren't changing, only this point is changing when I press. So how can I get control of changing the other two? Well, I do have more than one button on my mouse, so I could change that. But another alternative, I think, is to maybe hold down a key while I'm doing it. I want to see if I can get access to which key is being held down when I pressed as well. And then maybe I can hold down the 1 for one corner, and 2 for the other corner, and 3 for the third corner. Should we try that? So I'm just going to remind myself of what the processing reference tells me about key pressed, because I do have to be precise. Is it the key that was last pressed, the key that's currently pressed? So there's a key pressed variable here, different to a key pressed function. And all right, so there's a if key pressed equals true, so that's a Boolean that tells me if any key is currently being pressed down. Then there's also the key, which keeps track of the most recent key that was pressed down. So if I want to know if a key is currently being pressed down, I ask key pressed. And then if I want to know which key is currently being pressed down, I ask the key method. It's the example they've got here. So I can do that. So in my mouse clicked, what I'm going to say is that if, well, first of all, we're only going to do any of this if the key's pressed. So you can click around and we won't do anything unless a key's pressed. And we'll say if that key is equal to the 1 key, then please be resetting the 1 position for me. Else, if that key was the 2 key, then please be setting the second one else. So we'll actually have this go off no matter what other key you press, but in reality we're imagining that you're holding down the 3 key. Else set the third slot. Okay, so I'm expecting now that when I run the program, a mouse click will do nothing unless I'm holding down one of the numbers. So mouse click's doing nothing. I hold down 1, and now it's moved that 1 spot for me. Hold down 2, and it's moved the second slot, and hold down 3, and it's moving the other slot, so I can get this triangle just the way I want it. Okay, I'll tell you what might be useful, labeling those. That will help me quite a lot. So I'm going to put some numbers on each of the corners so I can see what they are. To do that, I need to draw some text on the screen. Text is fairly easy. You just put the text you want and the spot you want it. But we have to make sure that we're getting what we expect. I think I'm going to get a white number 1 here. I do. So that's a bit easier. I mean, it's hard when the triangle's quite small. The 1 doesn't show up very well, but it's okay when it's further out. It's enough to keep me knowing what's going on. And I'll do the same for the other one. Whoops. Okay, so that'll show me a bit more about what's going on. Maybe I'll make it in, that'll do for now. So that's enough for me to get the triangle just the way I want it. I hold down the 1 and I put that where I want it. I hold down the 2 and I put that where I want it. I hold down the 3 and I put that where I want it. Now I realize, no, actually I want this a bit further down here. So I'll hold this goes down and pick the new spots. That's a nice spot for that triangle. Now what? So I said I wanted to control kind of an animation, not just a single thing. How do I keep track of an animation? So at this point I've captured the state of the triangle right now, and I can reuse those X1s, Y1s for something else. But there's not much else I can do with them. I actually need to keep many of these X1, Y1s. X2, Y2, X3, Y3s. Many of them because there are many frames in any animation. So whenever I've got to keep track of more than one of something, I have to use arrays. And arrays are a nice, well, they're just unavoidable. They're great. An array is a variable that just have more than one thing inside it. So here, instead of saying all of these are integers, I'm going to say they're all integer arrays. And that means instead of storing just one thing, they store many things. So processing would immediately complain at me that x1 can't equal 10 anymore because x1 is no longer an integer. It's an integer array. With arrays, you can index into them. So x1 has a 0 slot and a 1 slot and a 2 slot and a 3 slot. So I can actually put integers in each of those slots, but I can't just make the array an integer. Also, when I build arrays, I have to build them slightly differently to how I build integers. With an integer, I just declare it and then fill it up with something. With an array, I have to declare it, then what are we doing over here? Declare it, create the space for it, and then fill it with something. There's an extra step, creating the space for it, and I'm not doing that here. Normally we create the space for it at exactly the same place as we declare it. So here's me creating a space for an array that can hold 4 things, and it means I'm going to have to do this the harder way. Now already this is getting awkward, but I will see this out a bit further before I make yet another refactor it a bit further. Oops, we're up to 4. Oh, it's not x1, x2, x3, I set myself crazy here. That's y1. And, oh no, there's an x3 and then a y1. Oh, should I use these here so that I don't keep getting confused? And then a y2. So now I've created a pile of different arrays that are all the same size. And they're actually all initialized with zeros. But these lines won't work anymore because x1 is no longer an integer, it's an integer array. But what is an integer is each of the slots. So I can actually put, just see if I can work out these column selections in VS Code. No, I can't. Ah, yes, I can. I can put an integer in each of the 0th slots. Now there's nothing in any of the other slots right now. Well, they're actually still 0, but we can make this program continue. Another thing that's not going to work anymore is that triangle can't just take in an x1. Triangle's 6 parameters are all integers, not integer arrays. So again, we have to say, look, don't just draw the integer. Please draw the 0th, sorry, don't just take the integer from each one, take the 0th slot from each one. And same down here. So this is all getting a bit awkward, right? Yes, it is. But it will work. And what these arrays are going to represent are the different frames of the animation. So this animation has 4 frames in total, only 4. And at the moment we're only dealing with the 0th frame. So all I did was take the exact same program, change it to use integer arrays so that it's ready to grow, and then set it all back to run the same way it did before by just only using the 0th slot of any of the arrays. So should duplicate field y3, that should be x3. And so we've got the original program back again. But let me explain what each of these looks like. So an integer, I'm going to do this in comments. An integer is just like a box that's got a number in it. So it starts off as a, how do I draw a box? Let's draw it this, bar. So that's a box. I don't have a nice thing for drawing on this computer yet, but I'm going to get one. So that's what an integer looks like. It's just a slot holding something. But what does an integer array look like? Well, I think of an integer array as a pile of these slots all next to each other. Yeah. So this one's 1, 2, 3, 4. I put one too many on there. So this would be two too many. This would be the array we just created with 4 slots, and we don't know what's inside it. But actually an integer array is a little bit more than that. An integer array is actually a slot that points you to the other 4 slots, because every variable in processing must just be a single slot, a single box. And you can't cram more than 1 integers into a single box. So what you do is you take a piece of memory somewhere and say this piece of memory has 4 boxes in it, and the box that I'm talking about, x1 in this case, just points you to that box, those 4 boxes, the places where they are. That's why we need the extra step of making the memory, because as soon as you declare a variable, you get the 1 box. When I declare that variable, I get the 1 box. That's not enough space for all my integers. I need a second step that creates the 4 boxes off somewhere else and makes this box point to them. So we've got a whole pile of boxes now. We've got many of these now, so they all look like this now. Right? Each of these variables can be thought of this way. And I'll see if I can get my vertical selection happening again. Yep. So each of these variables looks like this, and what we're doing in the program is we're only using this 0th slot on all of them. I still haven't quite got the vertical selection thing sorted, obviously. No, that's not good. We're just using this slot here on each of them, and that slot is labeled. So this guy here is the actual variable, and this guy here is the 0th slot. That's the 1 slot, the 2 slot, and the 3 slot. So even though we said this had 4 spaces in it, the 4 spaces get labeled 0, 1, 2, and 3. So we're just using the 0, 1 over and over. And what we want to make an animation, we want to say, well, this was the triangle that belongs in the 0 slot, but what's the triangle that belongs in the next slot? How can we support that in the program? Well, what I want is for the user to be able to say, this triangle's done, please store it and move me on to the next frame so I can show you what triangle I want for the next frame. And that also means I need to keep track of which frame I'm on, right? So first time around I was on frame 0, and now we can see, oh, this 0 here that I'd kind of put in as an arbitrary number because I always wanted to use 0 actually is the frame I'm on. And of course I start on frame 0, but later on I'm going to end up on another frame. Yep. And this one here. So all these zeros become frames. They were magic number 0. Now this will still have the exact same effect because I've set that that frame variable to be 0, right? It's not anything else at the moment, but in a minute I'll change it to something else. So we're drawing this triangle every time. How do we advance the frame? How do we say, right, I'm done with this triangle, please do the next one? Well, a key press, probably. A nice one might be the space key, so I'll do that. So if they've pressed the space key, I'm in trouble getting out the space key, I want to say, we're done with that frame, I'd like you to move on to the next frame. So I want the program to start drawing the next frame. I want the mouse clicks to start affecting the next frame. And that'll all happen automatically if I just update this frame variable because it's in all those slots. So I make it go up by 1 and we're done, right? Let's see. So this is the triangle I want for the first one. And I say, yep, very happy with that. Space. Triangle's gone away. But look, the triangle was there, it's just a 0 triangle. And the 1, 2, and 3 came up. Good, so I've got a new triangle ready to go again, and I can do that over and over. So there's 2 problems here. The first, I don't know which frame I'm animating at any one point. And secondly, when you're animating, you want to be able to see the frame you've just come from so that you can make the next frame look nice. We can't do that yet. But let's first start with just showing the user which frame they're on. And we can do that by putting some text in the top right. So we want to say creating frame, and we'll put this somewhere. We got just trying to think. So when we do text, we're anchoring to the bottom left of the text. So my x coordinate wants to be something like width minus 100. That'll do for now, and height minus 20. I think I'm terrible with these. So there you go. So I did width and height. So I stuck it all the way down the bottom. I actually wanted it at the top here, but I didn't get. I wasn't too far off. So that should be actually more like 20 in the y. I do need that to come back a bit because I'm going to put a number next to it, which is frame. I'm going to put the actual frame number next to it, right? And that can be width minus 100 and y of 20. So if I run that. Okay, so the 0 is in the wrong spot because it's not actually width minus 100, it's more like width minus 20. There's only 4 frames, so I don't have to worry about 2-digit numbers. There we go. So we're creating frame 0, and I can put it where I want it, and then I press space, and I'm creating frame 1. So now it's easier to keep track of. Nice. And now frame 2, frame 3, frame 4, something crashed. When I tried to go to frame 4, I got an index out of bounds except, sorry, frame 5. Frame 4, sorry. Tried to get an index, I got an index out of bounds exception. And what happened there is that, well, we know there's only 3 frames, right? Killed the whole thing. I don't know how to stop that. It'll stop in a sec. Probably a Control-C will do the job. Terminal will be reused. Press any key to close it. Oh, okay. There are only 4 slots here, and they only have the label 0, 1, 2, 3. So when frame went to 4, there was no box for the numbers to go in. And when there's no box for your number to go in, you get an array out of bounds exception, which is exactly what we got. What we need to do is make sure frame never goes over 3. There's a cool trick we have for doing that. We can make frame go up as much as we want, as long as after we've made it go up, we then constrain it to be between 0 and 3. Processing reference has something helpful for that, but I'm going to do it by hand. So what I do is I say the new frame equals frame plus 1, right? But that might send it up to 4. So that it'll be 0, 1, 2, 3, 4, 5, a number. But I want that number to only ever be between 0 and 3. And what I can do there is I can say if I get that new frame number and I modulo 3, it's never going to be bigger than 3. And what do I mean by that? Well, 0, I'll put some in to show you. 0 modulo 3 equals 0. 1 modulo 3 equals 1. 2 modulo 3 equals 2, because it's dividing by 3 and then giving you the remainder, right? Oh, I should do modulo 4, I think. 2 modulo 3, sorry, 3 modulo 3 equals 0. I'm back around to 0 again. So in fact, I didn't want that to be 4, because I want this to go to, I want that to stay at 3. So 3 modulo 4, which is what I really want, is 3. And then 4 modulo 4 is back round to 0. So no matter what the number frame is actually turned into, it'll always get turned back into a number 0, 1, 2, 3. So if I keep pressing space, it'll go back around the loop of my animation by using that modulo trick. So the modulo trick is a way of constraining a number to be in the band you want it to be in. Let's see if that's done the job for us. So I'm creating frame 0, and now I'll create frame 1, 2, 3. And look, I went back to creating frame 0, and in fact I can just keep looping around them, doing all of them the way I want. And I can see my animation now. And if I just keep pressing space, I'm kind of replaying my animation. Okay, there's a lot more to do on this. I think we might do a bit more on this next time, but I'm going to leave it there for now because I quite like that. Okay, next week I'm not going to guarantee we'll continue doing the flipnote one, but I think it's a fun one to do. And the next thing to do on this is to jump into some objects, because having all these x1, y1s and some array operations as well, this is going to get awkward fast if we try and make bigger animations. And also the next thing to do is to move between modes. So I have a mode where I'm creating the animation and then a mode where I'm displaying it. And also to make the creation mode include the frame that's underneath it. Because that's how animators work, right? They look at the last frame and then they sketch the new frame over the top. We haven't done that yet. But again, quite a nice program, quite short, without using any magic. There was a bit of magic we could have done here. We could have used the built-in processing function that does that. Maybe I'll quickly processing reference, bring that up. The function I'm thinking of is one of these math functions, constrain. So the constrain function takes in a number and then makes sure that number is actually between two other numbers. So we could have done that. We could have taken the frame and constrained it to be between 0 and 3. But we did that ourselves using modulo arithmetic. And that's a really good example of what I mean by keeping things right down at the low level, explaining every little detail of what's going on in this process, trying to make sure there's no magic. All right, that is all for now. Thank you very much. See you next week.